Video, I'm going to go over the Hydrate Lab. A hydrate is an ionic compound that has water molecules loosely stuck to it. So in this case, we're going to work with barium chloride dihydrate. The barium chloride is just the same way we've always done ionic. Barium has a +2 charge, chlorine has a -1 oxidation number, so when you crisscross the numbers, you get BaCl2. The dot is showing you that the water molecules are not chemically bonded to the barium chloride. They're just kind of stuck to it. And we use the covalent prefixes for the amount of water molecules. So di goes with 2. We've done other experiments with hydrates. So for example, one we've used a couple times by now is copper 2 sulfate, right? So that's copper 2 sulfate, pentahydrate, right? So penta is going with the 5 for the water molecule. What we're going to do in this lab is we're going to take some of this barium chloride dihydrate, we're going to put it into a crucible and heat it to very high temperatures to cause these water molecules to evaporate. Basically, they are going to leave the structure. And what we are going to do experimentally is calculate how much percent-wise, how much water is in this whole hydrate compound. So what we are going to do is compare the percentage we get experimentally with the accepted value. And to figure out the accepted value, you're going to do a percent composition problem. So you break the compound apart. Now, since I'm figuring out the percentage of H2O, I'm going to keep H2O together. And there's only one barium. So you're going to do 1 times double molar mass of barium, which is 137.3. You have 2 chlorine, so you're going to do 2 times the molar mass of chlorine, which is 35.5. And now there's 2 water molecules. You use this one. So 2 times, and water's molar mass is 18.0. You're going to multiply those out. You're going to get numbers for these, and you're going to add them up. And that is going to give you the molar mass, the grams per mole for that whole hydrate. And now once you do that, remember a percent is a part divided by the whole. So whatever numbers you have here for barium, chlorine, and water, you're going to divide those by the molar mass, this overall number. So each one gets divided by that. You're going to get a decimal there, you're going to multiply it by 100, and that will give you the percent. So this is what you're going to get as the accepted value for percent H2O. Everyone in the class should have the same accepted value because we're all starting off with BaCl2.2H2O. Now in the lab, we're going to use the crucible. You're going to put a little bit of barium chloride dihydrate in here. It says, I think, about 2 grams. It doesn't matter the exact amount. Don't try and get it exactly 2, but you should write down the exact amount. Like, you don't have to go for any specific number. When we are going to do this, you're going to heat this up. So you have a Bunsen burner underneath. You're going to heat up the crucible. The water is going to evaporate, and what you're left with is going to be the anhydrous salt. The anhydrous salt in this case is just BaCl2, right? Because all of that gets evaporated. That's the anhydrous salt. And then we can figure out how much water was in there by weight. Now, usually when people use crucibles, they say to use the lid for it, right? And you put a lid on there to keep anything from splattering out. What's good about barium chloride dihydrate is it's pretty dense stuff. So when we heat it up, we don't really have to worry about little pieces of it flying out of the crucible. So we're not actually going to use the lid. And the reason why I don't want to is really for a safety reason. I've found over the years that if people get burned during this lab, most of the time it's because of the lid. For one thing, you have to leave it half on and half off, right? So water molecules can actually leave the crucible, right? So you kind of have this just positioned here, and sometimes they slide off. And what happens is if they start to slide off, what I have actually seen people do is not really thinking, and it's sliding off, and they try and catch it, and they burn their hands. Or if it slides off, it falls down and it cracks, and pieces go everywhere. And usually when something falls and breaks, people's immediate reaction is just to start picking up the pieces. So I've had more people get burned from the lids than anything else. And since we don't really need them, that's why I'm just leaving them off. What you're going to do is have the barium chloride dihydrate in there. You're going to heat it up for a certain amount of time. It tells you in the lab. You're going to get the mass. You're going to heat it up again for a certain amount of time, get the mass. If the mass doesn't change, it's telling you all that water that was going to evaporate has left. And you're going to write all that information down here. and it gives you hints of how to do some calculations, like it says B minus A, so you do B minus A. And basically what you're getting down to is the mass of water lost and the mass of the anhydrate alone, the anhydrous salt. The calculations that you want to do are on this page. Now, there is a document on Google Classroom that gives a lot of hints on this page. You definitely want to go there and write down all of those hints. That will make this lab a lot easier. Really what you're trying to get down to eventually is the experimental value of percent water lost and the expected value of percent water lost, and then you're going to calculate percent error. What is the difference between those two numbers? And then there's some questions that go along with that. But that is the general idea. Make sure you go to Google Classroom and get the help from that document.